Thank you. Yes, and I am actually here to say that there is no hopes tokens are coming to Bitcoin. And that's the kind of Pandora box. So I would like to start with the motivation about this topic. We saw all these magical Ethereum creatures like, Turing complete smart contracts, sharding, POS, Whisper, Swarm, Shasper, Casper, Plasma, a lot of different terms, ERC tokens, unstoppable world single-threaded computer, hackable DAOs, the DeFi speculations, nobody used dApps, and many marvelous things. So we decided that actually we would like to coming out that we are in fact with these RGB and Spectrum projects are jealous for Ethereum magic. However, when we thought after that, we still think that there might be some few legit cases for an assets over the Bitcoin. Namely, there are some classes of things that have to be covered in a quite decentralized way, like financial assets, including RU stable coins like Tether, corporate shares, bonds, futures. They are all centrally issued, and there is no point of decentralizing their issuance. However, you still need to have a free decentralized secondary markets that, for instance, may be even unregulated and untransparent. You may have a digital collectibles that they live their own life, and they can live this life decentralized. You can have a voting rights. You can have a special access authentication type tokens granting you rights to access some data sets or other digital items. And additionally to having free secondary markets, there are also cases for interoperability, because when you have an industry-wide open standards, it is much easier to establish and integrate different systems. It reduces the total cost of ownership. And I think the strongest one is that we really need to make a lot of these things to be private and not transparent on the global blockchain, being able to be trackable by systems. So to bring a zero knowledge into this world and to enable, even if you need to audit something, that you would be able to do that without knowing the details with zero knowledge proofs. There was a lot of projects directed to assets on top of Bitcoin. Namely, it was started with a colored coins project, then there was a counterparty, Mastercoin, later renamed into OmniLayer, and today we have very good standard for confidential assets. Unfortunately, it works only on Liquid right now. But why we are trying to do some next standard? We are trying to fix, first of all, the privacy of all of those standards, except the confidential assets, which are private sufficiently. We need to get rid of miners' censorships, because if miners, seeing that there are some assets in the transaction, they might censor this transaction. And also, there is a distortion of minor economic incentives, because if you put an assets, for instance, for global companies onto Bitcoin blockchain, their total capitalization will be larger than the market capitalization of Bitcoin itself. And it will distort miners' incentives to censor specific types of transactions related to the transfer of that asset. So we need to get rid of this problem before bringing any assets into Bitcoin. We need to prevent the pollution of blockchain, because blockchain doesn't scale, and you can't use it as a decentralized database to store arbitrary data, including any kind of shares or Tether or whatever you would like to bring there. And of course, we need to make something that can work with a Lightning Network and that can even support L2. And also, we would like to get rid of this idea of utility tokens and other ERC20 tokens and start talking more about financial assets, collectibles, and classical asset types. So this project a little aim of this project is to harden the ICO as much as possible. So we have came with this idea of RGB. It has originated from Giacomo's work and has inspired by a lot of Peter Todd research. I will be talking about that later. And the main properties of this technology that is being designed over the last 2 years or maybe more, it is a layer 1 I can't pronounce that word from the word of crypto, but you know what it means. Basically, we are consuming no blockchain space. I will describe how it is possible later. It is private, so transactions can't be distinguished. Transactions with the assets, they can't be distinguished from the transactions that not transferring any assets. And we have no minor incentives distortion. So how we design this technology? First, we are starting with fixing privacy. A great idea by Peter Todd, client-side validation. I all propose you to see it if you haven't seen it before. The idea is very simple. Let's put the data off-chain. If there is somebody who needs to access those data, he needs to access those data. If the rest of the world have no reason to see this data at all. So let's keep it on the client side, and it will be a client who will validate the data, not a global consensus. I'm just putting that in very simple words. Peter, if you read these papers and hear his talk, he is also explaining the same thing, but in much more complicated way. So you can watch for that if you need to have it in more scientific definition. Why do you need to move to the client-side validation? The basic idea that you need to break the loop of attribution, this famous OODA loop, that you can't be punished or judged by governing bodies, by the regulators, if they can't observe and attribute who owns who. So that is the core of the privacy design. Is it enough? Is it enough that we will keep information about the assets only by those who own them and they validate that? Unfortunately, it's not enough, because we have this famous problem why we have a Bitcoin and proof of work is the double spend prevention. So it seems that we still need some kind of blockchain, because when there is a need for global consensus algorithm preventing double spend, we have to have blockchain. But there is another very good known best practice. So if you do need to create a new blockchain, you actually don't need to do that. So we stick to this best practice. And what we have found that Bitcoin blockchain already prevents double spend. And maybe we can leverage it. And yes, we actually can leverage that, because we can commit to client-validated data by putting the hashes of this data into the Bitcoin transaction graph. How we can commit to something? Well, there is very good standard coming from a good idea, coming from Eternity Vault, based on the homomorphic property of the elliptic curves. So if you have a public key and a private key, and you will add some number, the same number, to both of them, the new public and private key will still match, and you can sign with a private key the transaction to spend that amount. So if you have some hash of the data, you can add it, you can convert that to elliptic curve point by multiplying on a generator. You add it to original public key, you got a tweaked public key. And when you need to spend this transaction, you do the same. So your transaction is basically ending up that you assign, you spend some Bitcoins to some output, and instead of the original public key, you put another public key. And any other party can't distinguish, did you use your own public key or is it a tweaked public key? Because they look the same, it's just some public key. And it is impossible to know that there is some data commitment that are added to this public key. So the original idea was just to use this standard. However, it happened that since the original idea, a lot of stuff started changing. And first of all, we understood that we need to have a taproot compatibility, meaning that a lot of different projects starting using this idea of pay-to-contract commitments. And when you commit to some data off-chain, you need to know how to interpret those data off-chain. And it can be, there is a possible attack that you prevent some off-chain data committed with one protocol to another protocol, and you will still have some byte sequence that can be interpreted like a script under some other protocol. So you need to harden that, and there is a proposal in Taproot, BIP Taproot, how you can do that with a special tagged hashes. So we need to add that to Eternity Wall idea. Also, we need to make sure that we can commit into not just to pay-to-public key hash outputs, because if you would like to use that on top of Lightning Network, we need to be able to commit into pay-to-witness script hash outputs. That is not defined how to do that in a proper way. So we have created more generic standardization proposal of a generalized idea of pay-to-contract that also covers pay-to-script hash, pay-to-witness script hash, and adapts that idea from the BIP Taproot on the tagging of the commitment hashes. And we understood that this and some other standards that we are doing for RGB, for assets, they are quite generic. They are not only related to assets themselves, because this standard of the cryptographic commitments, it can be applied to many different cases. So we have decided to create this GitHub organization named LNP-BP, where we are creating these small modular standards, defining some best practices. These standards, they are lying outside of BIP interests. So for instance, they are not affecting the soft forks or hard forks. They are not affecting Bitcoin monetary functions, but they are still standards. So we have created this standards repository, and I will be talking about that a bit more later at the end of the presentation. So we now know how we can commit to some data with Bitcoin outputs. But is it enough to solve the double spend problem? No, that's not enough. So we need to use another concept, which is named single-use seal. Again, it comes from the Peter Todd. Here its definition, the idea that basically the Bitcoin transaction output can be double spent. And we utilize this property of the Bitcoin transaction output, and we are binding something to this transaction output in a way that if the transaction output spent once, we are sure that the data bound to that transaction output are also committed only single time. So how it works? We define such a structure as a seal. I wouldn't spend much time on that. Again, if you are interested in this technology, it's better to read and listen to the original Peter Todd talks. Yes, but very briefly, we define a seal. We agree that this transaction output specific has some special meaning. We agree on the commitment procedure that we use to commit to, basically. And when this transaction output is spent, it can be proven easily because the spending transaction is the actual proof. And the thing that spending transaction, we put a commitment to some value. And this value is basically a hash of some original message or data that we would like to commit to. So with this single-use seal construction, we can prevent a double spend. Here is an example, like we have a transaction, we say that this transaction output seals some data. Well, this is a seal, this transaction output is a seal, and there is no data we are not adding any data into this output. It's just our agreement between different parties. There is nothing on chain here. And when this transaction output is spent, this is a witness, the transaction that spends this seal, and we add this cryptographic commitment into predefined output number, which can be deterministically defined in the same way by all the parties who are trying to verify this. And this tweaking factor we add to original public key is actually a hash of some message. So we close this seal over this message. That's how it works. And with these seals, we can actually build some history of a state, because there could be multiple assignments of the seals, multiple definitions of the seals, and each time the seal is spent, we commit to some other message that assigns data to new open seals, and so forth and so forth. So we can have a chain of seals, or even a tree of seals, or even a DAG of these off-chain client-validated seals. And what are the messages? The actual messages are the state transitions, because if you would like to send some assets, like USD Tether to other party, it is a form of state transition. So you can put transactions into client-validated off-chain data and use single-use seals, connected single-use seals, to build a big off-chain data structure that can still be validated against any double spends. So we have this data, and this information, these messages that you keep off-chain, they consist of such parts like a list of the seals you're agreeing upon. You're saying that this transaction output has this meaning and has this data associated with it. So we name that associated state, which is bound to that seal. We can add even a script with a simplicity language, defining the rights or defining the conditions of the spend. It is important to understand that these scripts are not replacing Bitcoin script functionality, because it is Bitcoin script in the output that defines who can close the seal, meaning that who can spend that asset. But you can also, on top of that, you can add additional conditions preventing from such spends. So you can't broad the restrictions comparing to Bitcoin script, but you can narrow it down. And some metadata, which covers all the seals defined by some state transition data structure. And we end up that we actually have a kind of, for each asset, we can have a chart of state transition DAG, which using single-use seal bindings is actually committed into Bitcoin blockchain in a well-defined and verifiable way. So how we can bring that into Lightning Network? Well, we can add public key tweakings into commitment and HTLC transactions. It's not a big problem. It can be done with a bit more extended C-Lightning plugin functionality, and we was already discussing that with Christian Decker. We also need to utilize these TLV message extensions, a new standard added to Lightning Network bolts. So we can add arbitrary data to pass client-validated state across the Lightning node and communicate about different parameters of the asset transfers. And also we need to, unfortunately, a bit fix the bolt specs, because at this moment they're not actually covering the whole the whole way the Lightning Network works, and they are very fluid, being updated quite frequently. So we would like to talk on the next Bitcoin, the Lightning conference in Berlin, to the teams involved into the standardization process and encourage them to make it more robust, the standardization process more robust and more formally defined. So here is a structure of the Lightning channel for some Lightning node. These transactions are asymmetrical, but I'm just showing a single transaction for one of the nodes. And basically we are adding these tweaking factors to public keys into some specific outputs or output scripts. And these are actually commitments to some off-chain data, and this off-chain data covers the balances of the assets across the party in the same way like transaction outputs cover the balances in Bitcoins. So when you transfer some asset, you actually again update the commitment transaction, so you can transfer some above dust limit of Satoshis and some asset, and you update the same time the commitment transaction and the off-chain states that is specifying which amount of the assets this node owns. So this is more enlarged case how we can just use two remote output to add this tweaking factor. We can go even further, because if we are doing a multi-hop payments in Lightning Network, it could be that I would like to pay Alice here is Bob. I would like to pay Bob some USD tether, and I have a good USD tether channel to some other node, but there is no route between us that has a USD tether liquidity. So there could be nodes that will announce their desire to be a liquidity provider and act as exchanges. So they will publicate the information about their bid and ask price for USD tether to Bitcoin and vice versa exchange. So I can construct the route with Bitcoin channels between this party. The only thing that I need to find is to find these two exchange hubs. So I still can transfer USD tether from Alice to Bob through some Bitcoin liquidity, and this transaction will be even more private than the normal Bitcoin transfer. So we name this technology Spectrum, so that's the difference between RGB and the Spectrum. RGB are assets, and Spectrum is liquidity mechanism and decentralized exchange that allows them to work on top of Lightning Network. We use Gossip protocol to publish information about ask and bid prices, and actually it allows to create liquidity providers to help multi-hop payments. The most important part that it is a new monetization model for Lightning networks, and Adam Back was already talking about the same idea that they had for confidential assets. Because it's a very good. Now you are not just routing the payments, but you're also providing liquidity, you earn something, and there is some mechanism that you can use to hedge your risks. Again, Adam Back gave some insight on that a day before. Basically, it is decentralized secondary markets, which are very private, and this technology, it breaks many ways how you can analyze the Lightning Network transactions and traffics. Because today, you can just, with the Gossip messaging, you can monitor the balance of different nodes, and you can guess all the multi-hop payments which are happening in the Lightning networks. I was talking to people who are doing this kind of research, and they are saying that they are unable to decode like 90% of the payments inside the Lightning network. Here, because we are not transferring Bitcoin amounts, we are transferring assets, and the actual transfers of the Bitcoins, they don't reflect the actual value transfer. And also with the Spectrum, with this liquidity exchange on the root, you can't associate different hops on the root with the same payment. So it actually enhances the security of the Lightning network itself. So as a result, these RGB and Spectrum proposals, what they allow us is to add multiple privacy enhancements into Bitcoin and Lightning network with a client-side validation, with a zero knowledge, because it is not that rest of the world doesn't know his actual owner and doesn't know which transaction transfers which assets. But it is that when I receive the client-validated history of the asset, if I'd like to receive a payment, I need to validate it, and I see all the previous owners. At least they are public keys, and they are transaction outputs. But I can hide the information about amounts being transferred even in the client-validated data by utilizing zero-knowledge like technologies like bulletproofs. And that's one of the points we would like to share some joint effort with the blockstream and confidential assets and transactions, because we see that this part can be very important for the RGB as well. And it also hardens Lightning Network asset transfer analysis, as I just described. Also, with this technology, we would be able to bring USD Tether, that is the core interest, for instance, of Bitfinex, who is one of the main participants of the project, into the Lightning Network and help to build an adoption, because price volatility of Bitcoin, it is one of the main factors that prevents merchants and users from using it as a mean of the payments today. If you will have an USD Tether in the Lightning channel and you can pay with that, it actually helps to build adoption around the whole Bitcoin ecosystem. And we are also working to find the best way how we can actually bring Bitcoin itself from on-chain transaction into this RGB system as off-chain Bitcoins to be transferred even in more private and scalable way than can be done today with the Lightning Network. But it's early work in progress, so I'm not sure that it's possible to do, but we are looking into this direction. So I'd like to spend some time to explain how it all sticks together, because there is a lot of discussion about layer 2, layer 3, complex numbers, how they can be used to make this layerization even more clear, because we have blockchain, side chains, Lightning Network, and whether the side chains are layer 2 or layer 2 plus E or something else. So I was inspired yesterday by Giacomo's triangles, and I already spent about 2 months trying to layerize all the technologies that we have in Lightning Network, Bitcoin, and everything that is built on top of that, and all of those attempts just failed. I even came to quaternions or something like that. But after this perfect triangle presentation, I understood that with the triangles it can be expressed even much more, much more better. So we have a Bitcoin blockchain. It's a kind of layer 1. It's based in the proof of work. Maybe you can put it here. And next to it, we have Liquid, which is sidechain. It is dependent on Bitcoin blockchain from one side, but it is already a next layer scalability solution. So we're not distinguishing this like two completely distinct layers, but they are very interconnected. Next, there is a Lightning Network, which can work not only on top of Bitcoin blockchain, but also on top of Liquid, and it can be even a bridge between the Liquid and Bitcoin blockchain. Now, when we come with the RGB assets are the client-validated data bound with the cryptographic commitments, and they can operate on top of Bitcoin blockchain, Liquid, Lightning Network, and work also as a bridge for assets between them, and if at some point we will be able to bring their off-chain Bitcoins, even for Bitcoin transfers between them. On top of that, grounding on the Lightning Network onion routing protocol, we can build a decentralized exchange mechanism like I just described for the Spectrum protocol, which will operate those assets using the Lightning Network onion routing functionality. So here how we put different parts of this LNPBP stack into this graph. And using all of these systems, we can actually build an application for storage, messaging, assets, and even computing. So if we would put instead a Lightning Network, a generic state channels, we will have L2 at some point. I think with the Schnorr signatures, there will be a multiple new projects for N of N multi-party state and payment channels. So I will just generalize that from Lightning Network into a more common standard, like going from Liquid to different types of sidechains. And here, not only RGB, but a whole set of client-validated rich state using applications can emerge. And on top of that, it can be bound all together with this onion-rooted, economically incentivized private messaging that can be done with current bolt specification. So we name all this triangle as a LNP-BP technological stack, Lightning Network Protocol dash Bitcoin protocol, because it's actual technological stack and framework for building these applications in a truly, well, I wouldn't say truly decentralized, but quite a distributed manner and very stable and economically incentivized manner. So coming back to this Ethereum magic, I think this triangle actually embeds a lot of this Ethereum magic by done in the right way. So we have this sharding here, we have these DAOs that can be designed at these layers, we have this better whisper as an onion-routed messaging, we can do a post-staking because state channels, multi-party state channels or escrowed contracts that they can be used as a staking mechanism, plasma chain, whatever. So actually, my thesis is that LNP-BP allows to do everything that can be imaginably done with Web3 or so-named Ethereum 2, but in more scalable and secure way. Maybe one day it can even help to fix these problems of the current TCP/IP standards, like privacy, poor censorship resistance. Current internet doesn't have embedded economy, doesn't have any escrow type solutions. One of the reasons why different forms of decentralized DOS attacks emerges, and build a better decentralized systems. That's why we started this LNP-BP standards initiative, trying to put anything that lies outside of the core BIP standards in a modular and usable way. So different projects building different technologies and solutions on top of Lightning Network, on top of Bitcoin itself, they can just utilize these some well-defined best practices. There is already a number of standards being prepared at this moment. They are not covering just an assets. It's like state history, graphs on Bitcoin, generalized commitments, and so on, so forth. So at the end, I would like to make this citation of Adam Back that I hope that we, as Bitcoin, I wouldn't say elite, but people who are really interested in Bitcoin will be able to build much more than just simple payment solutions. So today we are working on financial sovereignty with the Bitcoin itself and different technologies allowing decentralized or trustless financial assets. A lot of work is put onto building proper privacy solutions. This can be utilized to build better storage systems. Like we have this proposal for decentralized storage and messaging using escrowed contracts and multi-party state channels. You can use that to build even a decentralized computing, censorship-resistant high-load computing, which we are doing with the Prometheus protocol, and maybe one day even come to ultimate sovereignty, which is digital immortality. So if you'd like to find out more, please look into this repository. There are also separate repository for and applications like RGB Spectrum itself. I already mentioned Storm for storage and messaging, Prometheus for high-load computing. And we have a lot of people cooperating on this part already today, so I would like to ask everybody interested to join it. Thank you very much.
All right, do you want to do questions and answers? I see hands raising.
Hi, you do a lot of research on AI segment and blockchain also, and I want you to ask you, probably you already know that Google tests quantum computer on 75 qubits, and I wanted to ask you, how do you think the quantum computing influenced Bitcoin and mining?
It is the question that has to be present at each Bitcoin conference. Unfortunately, maybe I'm wrong person because I'm not quantum computing expert, and it's maybe more appropriate to ask Giacomo. But frankly speaking, the simple answer, it would not affect in the time of at least next 5 to 10 years, because it is over marketed right now, and basically the only thing that can be broken with quantum computing today, it is not a hash function, so it wouldn't affect mining itself. It is, you can break elliptic curves, and it means that if you have pay to public key outputs, they're in danger, and you can easily mitigate that by just spending into pay to public key hash output. So there should be some work be done already on crypto, on quantum resistant cryptography, but I don't think that we have to be in rush implementing hard forks or anything just to resist this not yet existing, not overestimated danger.